Hi everyone, my name's Oak, and today I am going through the common HSC exam questions to both Advanced and Standard 2. Now, there are 5 questions in this paper that belong to both, which contributes to the common section of Standard 2 and Advanced, okay? Now, let's have a look at the first question. The first question is question 24, that's common to both. It said there are 2 tanks on a property, tank A and tank B. Initially, tank A holds 1,000 liters of water and tank B is empty. When we read this question, I said initially, that means at time t equals to 0 straight away, okay? At t equal to 0, tank A holds 1,000 liter, okay? So V of A must be 1,000 L, okay? Now, and tank B is empty. I'm going to use blue for tank B. So tank B is empty. That means V of B must be 0 L, okay, based on the given information. Tank A begins to lose water at a constant rate of 20 liters per minute. Now, when you read this statement, lose water at a constant rate, okay? Lose water at a constant rate. When you're hinted with this phrase, right? Lose water, that means the volume is going to decrease over time, correct? When we lose water, okay, volume decreases over time. Now, this means we are going to get a straight line or a linear graph, correct? Because it said constant rate, okay? So decreasing, okay, linear function, yeah? Or what we can say is it has a negative gradient, yeah? Now, what does that 20 tell you? It said constant rate of 20 liters per minute. When you read this carefully, per minute, right? In 1 minute, how much volume has changed, okay? In 1 minute, how much volume has changed. So if you look at the graph that's given to you, we have V that represents the y-axis in this case, and then we have T, which represents the x-axis. When we investigate the definition of gradient, 1 unit change in x, we want to investigate how much y has changed, right? So when x increased by 1, how does y change? Does it increase or decrease by how much, right? In this case, that's pretty much the same thing. In 1 minute, right, which represents the x-axis here, how much volume has changed. And so we can say that this information is the gradient, okay, of tank A, right, or the volume of A. The volume of water tank A is modeled by this equation, and so when you read this equation, that should come to you straight away, that negative 20, that is the gradient, you see? And 1,000 here is the initial value, okay? Where V is the volume in liters and T is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as tank A. Now, let's look at tank A. Tank A, or the volume of A, is given by 1,000 minus 20t, okay? So when you want to draw a linear graph, or when you want to draw a straight line graph, well, you're given an equation in this case, so we need to just find 2 points that lie on this line. The 2 easiest points are the points where, well, when you go back to x and y, when x is 0, what happened to y? When y is 0, what's the value of x? Essentially the same thing here. At t equal to 0, okay, because T and V in this case represent the x and y values, okay? At t equal to 0, what happened to the value of V? You're given that. At t equal to 0, when you substitute t equal to 0 in here, you would find that this goes to 0. And so we would just have 1,000, okay? So at t equal to 0, V of A is 1,000. Now, what's left? We need to find another point because we have 1 point here. We have 0, 1,000, okay? Let's find another point. Another easiest point would be when V is 0, that means when the tank gets empty. At V equal to 0, or VA equal to 0, we would have that, we're going to substitute this value, yep, into V of A, okay? So 0 equals to 1,000 minus 20t, that means 1,000 is 20t. When you evaluate this out, we find that it takes 50 minutes for us to empty the tank. Now, let's put the 2 points in. So we have 0, 1,000, and we have 50, 0. After 50 minutes, okay, the tank gets emptied. We're going to join these 2 lines, and that's going to make the graph of tank A. Yep, and this is tank A. Okay. Next, let's have a look at the next question. It said, tank B remains empty until t equals to 15. That means we're not going to fill in any water until t equals to 15. That tells me what? That tells me that from 0 to 15, the volume of B remains at 0. So this is one thing that I can do. I can just draw a straight line from 0 to 15 that represents the volume of B. So from 0 to 15, nothing happens. There's no water that goes into the tank, okay? Now, let's read on. It said, well, water is added after 15 seconds, okay, at a constant rate of 30 liters per minute. This is a keyword right here. Constant rate of 30 liters per minute. That tells me after every single minute, okay, the volume of water goes up by 30 liters, okay? So every minute, the volume goes up by 30, right? So for VB, okay, every minute, okay, V goes up by 30 liters, okay? So let's have a look at the scale. The scale looks a bit weird here, right? The scale here in your graph goes by 15 to 20 and then 20 to 25, so it goes up by 5, right? But if the given information said every minute, right? How about we investigate something a bit more and said, what about every 10 minutes? Can we just multiply the volume by 10? Yes, because it's constant, right? It's given that this goes up in a constant rate, right? So every 10 minutes, V goes up by 30 times 10, which is 300 liters. That means over an interval of 10 minutes, my volume would go up by 300 liters. So between 15 to 25, that's when the water gets added into the tank. My volume would shot up to 300 because it starts off with 0, so it should go up to 300. What happened after another 30 minutes, another 10 minutes? Well, it goes up by another 30, right? So let's put a few points there. After 10 minutes, okay, after 10 minutes between 15 and 25, the water should go up by 300. So we have this point here, okay? And after another 10 minutes between 25 and 35, that should go up by another 30, right? Now we have 2 points, okay? Don't forget that you have this point as well, so we can just draw the line across these 3 points, right? Yep, that's not the best line. Yeah, all right, that looks good, okay? Let me just continue on a little bit more. Okay, all right, so that's another straight line, okay? And now we're going to label this as tank B. Okay, that's tank B. So we have 2 graphs now, one for tank A and one for tank B, okay? The question said, by drawing a line on the grid on the previous page, or otherwise, find the value of T when the 2 tank contains the same volume of water. When the 2 tank contain the same volume of water, yeah, we are looking for where the 2 graphs intersect. Okay, now for standard students, you may want to interpret from the graph. For advanced students, if you can construct the equation of this straight line, you can solve them simultaneously. Okay, so where the volume is equal, that means where the 2 graphs intersect, and that means we have this point of intersection right here. Now, if I draw this out, okay, I'm going to use green. I'm going to have that point of intersection, right? So I'm going to find out at what time that happens, okay, and at what volume that happens, okay. So if you read the graph, we see that this here is 420 liters, and that happens on the 29th minutes, okay. That happens on the 29th minute. So find the value of T, okay. So I can say from the graph, yeah, the 2 tanks contain the same volume of water at T equals to 29 minutes. Okay, and That is the answer. T equals to 29 minutes for this question. All right. Now, using the graphs drawn or otherwise, find the value of T when the total volume of water in the two tank is 1,000. That means the volume of two tanks, okay, the volume of water in two tanks is 1,000. That means the sum, okay, of VA plus VB equals to 1,000, okay. Now, for standard students, you can interpret from the graph, so you just screen through from left to right to see where you can add the volumes up to 1,000, okay? How about we start here at the point of intersection, all right? At the point of intersection, you have 420, that's when they add up to 840, right? Because the volume of A is 420, the volume of B is also 420. When you add them up, you have 840, which is not the answer. We want them to add up to 1,000, okay? So if you screen the graph carefully, okay, you can see that on the 45th minute, right, the volume of water in tank A here is 100 liters, correct? And at the same time, what is the volume of water in tank B? In tank B, that is right here. In tank B, you have 900 liters of water. Okay, so 900 plus 100, that makes 1,000 liter. Okay, so the answer would be at 45th minutes. Okay, so the total volume of water in tank A and B is 1,000 liters at T equals to 45 minutes. Okay, and that is the answer to this question, right? At T equals to 45 minutes. Okay, now that's the first question, right? One question down. Okay, let's have a look at the second one. Mr. Ali, Miss Brown, and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 35 degrees for 7 kilometers. That means we need to know which direction, or how do we read the bearing in this case. So if I zoom this in a little bit, okay, Mr. Ali, that's represented as A, he walks on a bearing of 35 degrees. So I'm just going to label this angle as 35 degrees here, okay? So that's this angle right here, because we're going to measure the direction bearing from the north. So from north all the way to where Mr. Ali is, that is 35 degrees. Okay, 7 kilometers is annotated for you to location A. Miss Brown with the rest of the students walked with a bearing of 100 kilometers for 9 kilometers to location B. Okay, now it's a bearing of 100 degrees. So if I have the compass set up at point P, which is expected of you, right? So we would have this information. We'll have two extra information. Number one, we would have that this angle here must be 55 degrees. Why is that so? Because if this is a north line and this is the east line, this angle must be perpendicular, right? Because north and east are perpendicular to each other. So this 35, that must be 55, okay? And it said walk on a bearing of 100 degrees. 100 degrees is measured from the north line. 100 degrees is going from north all the way to this line here. So if this 2 already makes up 90, that means this angle must take just 10 degrees. So we have 10 degrees right here. Okay? Show that the angle APB is 65, right? So there we go. Okay? We have shown that the angle APB, which is this angle, okay? What I can say is by constructing, okay, by constructing east-west line, okay, we find that angle, let's call that east, okay, angle APE is 55 degrees and angle EPB is 10 degrees. Hence, angle APB is 55 plus 10, and that is 65 degrees. Okay, so that is one question down. All right, it said now find the distance AB. Okay, find the distance AB. So if I draw up the line AB, which is this line here, Okay, how do I find the distance AB? Let's see what information do you have. Yep, the information that you have is we have two sides sandwiching this angle in the middle, and that tells us to use the cosine rule. Okay, we have two sides sandwiching in between, and we're going to find that missing side there. Okay, so that tells us to use the cosine rule. So before I use the cosine rule, I'll say we use the cosine rule. Okay, use cosine rule to find the length AB. Okay, now let's write down the equation first. So we have AB squared equals to AP squared plus BP squared minus 2 times AP BP cosine of angle APB. We know that the angle APB was found to be 65 degrees in the previous question, so we can use that. Okay, so AB squared must be 7 squared plus 9 squared minus 2 times 7 times 9 cosine of 65 degrees. Okay, and so when you calculate this out, right, you would have that AB here is 8.76 kilometers. Okay, AB here is 8.76 kilometers. Now make sure you save this, right, store this, okay, in calculator. Okay, store this in calculator. Now, so that's distance AB. The key here is to use the cosine rule. Okay, so we need to be able to realize that we need to use cosine rule here. Now find the bearing of Miss Brown's group from Mr. Ali's group. Give your answer correct to the nearest degree. Okay, you want to find the bearing of Miss Brown's group from Mr. Ali's group. So Miss Brown, bearing of B from where? From A, correct? You want to find the bearing of B from A. So if you are, okay, if you are standing at A, yeah, you want to find out where B is, okay? So if you're standing at A, you want to find out where B is. So let's look at this diagram in detail, okay? Let's set up a compass on A, and we are going to find the bearing, which is in this shaded red. Okay, we want to find that angle there. Okay, so that's the north, that's the east, that's the west. Okay, so we want to find that shaded angle right there because we want to find B where you're standing at A. So based on this information, let's use the property of the parallel lines. Okay, now if you look at this Z shape here, okay, this north and that north, okay, are parallel. And so we can say that this angle is 35 degrees as well because that's alternate angle. Okay, that's alternate angle. Let me just point this as A. Okay, now how do we find that missing angle? So we want to find this missing angle, yeah, in purple. Okay, if we can find this purple, yep, if we can find this angle in purple, then we can find the shaded angle in red, right? And this purple angle can be found from here. We have this distance AB, right? Just now we found that this distance AB was 8.76. Yep, this is 8.76 K. Okay, so what rule are we going to use to find that missing angle in purple? You see, you have this angle and you have the side opposite the angle. You have the side opposite this angle, so we can use the sine rule here. Okay, so we're going to construct the sine rule. Okay, so I'm just going to annotate here, right? And you can write down, okay, in the relevant section in this empty space. Okay, I just need to use a diagram. So use sine rule. Yep. We have that sine of 65 over that distance. Okay, so sine of 65 over distance AB, yep, which is 8.76. That must be equal to sine of PAB divided by 9. And that's the equation that we have. Okay, Now I'm going to transfer this down to that section. Okay, so if we use sine rule, we have that sine 65 degrees over 8.6, okay, equals to sine of PAB over 9, right? We want to find the angle PAB, okay? So angle PAB, yep, we have 9 times sine 65 degrees over 8.76, and that's equal to sine of angle PAB, okay? When you calculate this out, we would find that angle PAB is sine inverse of 9 sine 65 degrees over 8.76, okay? And that angle PAB is 68 degrees, okay? 37 minutes. Yep. If angle PAB is 68 degrees and 37 minutes, okay? So this is 68 degrees, this whole thing, okay, is 68 degrees, 37 minutes, okay? What is that purple angle? The purple angle here would be 68 degrees, 37, okay, minus 35. Yep, and that is 33 degrees, 37 minutes, okay? So that purple angle there is 33 degrees and 37 minutes. Hence now we can find the bearing, okay? Now we can find the bearing. So the bearing of, okay, therefore, the bearing of B from A is 180 degrees minus, what is that? 33 degrees, 37 minutes, which is 146 degrees, 23 minutes. Okay, the bearing of B from A is 180 degrees minus 33 degrees, 37 minutes. And that is the answer to this question. Okay, so this is a very complicated question. Okay, I would admit that, right? Because it uses so many rules. It uses both cosine and sine rule. And what's more, if you don't construct that compass, right, that I've drawn here, okay, then it is very unlikely that you would be able to do this question. Okay, so this is probably one of the harder ones as well. Okay, now, so that's the question 31. Okay, now let's move on to the next one. Question 32. It said the diagram shows a regular decagon. Okay, a decagon is a 10-sided shape. So in this case, it looks like a 50-cent coin. All right. The decagon has a center O. Right. The perimeter of the shape is 80 centimeters. Now, if it is a regular decagon, okay, that means the side length AB and this side length here, all of these should be equal. Do you agree? Yeah. So there are 10 sides. Okay. So if the perimeter of the shape is 80, that means AB must be 80 divided by 10 because there are 10 sides. So that's 8 cm each. Okay. So that's 8 cm each. Now, the diagram has been given to you already. Okay. So we have a triangle ABO. Okay. By considering the triangle OAB in this case, calculate the area of the 10-sided shape. Give your answer in square centimeters, correct to 1 decimal place. So because this is a regular decagon, what we can do is we can find one of these triangles, we can find the area of one of these triangles, and then we multiply that by 10. Because if you divide this up, how many triangles are you going to have of the same shape? You're going to have 10 of them, okay? So you're going to have 10 shapes, 10 of the same triangle, right? Now, what else can we do? Well, we know that this side length here, AB, is 8, right? We need more information than this. We can find this angle, AOB. Because the sum of angles at a point is 360 degrees, and because there are 10 triangles, there are 10 middle angles here, okay? So the sum of, since the sum of angles, okay, at a point is 360 degrees, right? the angle AOB, that must be 360 degrees. You have 10 of them, so we have divide by 10, and that's 36 degrees each. Okay, so that angle in the middle there, that is 36 degrees. Okay, that is 36 degrees. Now, if this is 36 degrees, can we find this angle? Well, because you're given that these two sides are equal, that tells me that this must be isosceles triangle. Correct? Because, well, you have isosceles triangles are triangles that have two sides are of equal length. And in this case, we can find the angle ABO. The angle ABO is, what is it? Well, because the sum of the entire triangle has to be 180 degrees, this must be 180. We already taken 36 degrees, and then we need to divide that by 2 because it's shared between angle A and angle B. And so when you calculate this out, okay, we would have that this is 72 degrees. Okay, 180 minus 36 divided by 2, that is 72 degrees. So we have this angle as 72 degrees. Okay, now we still can't find the area yet. Okay, so obviously this working, okay, needs to be in here as well. Okay, let's just construct this properly. Yep, since ABO, since triangle OAB is isosceles, okay, we can find that angle ABO must be 180 minus 32 equal to 2. That means this angle must be 72 degrees. Okay, now that's step 2, right? In step 1, we found the angle in the middle. In step 2, we found another angle. Okay, step 3, what do we do? What do we do next? To find the length, sorry, to find the area of AOB, right? So the big plan, right? The big plan, okay? The triangle AOB itself, yep, the area of triangle AOB, that's half times OA times OB times sine 36 degrees, isn't it? Yeah, because the area of a triangle is 1/2 AB sine C, correct? So we need to find, okay, we have the half. Do we have sine 36? Yes, that can be calculated. Do we have the length of OA or OB? No, we don't. But what we know is OA and OB are equal, right? So here we can use cosine rule, okay? We can use cosine rule. Why is that so? Because we have OA and OB of equal length, which are the unknown in this case. The unknowns are the same. And we have this 36 degrees, which is the angle sandwich in between the two unknown sides. And we have this side opposite to the unknown angle. So yes, we need to use cosine rule here. Okay, so in step 3, use cosine rule to find the length OA, which is equals to the length of OB. Okay, let's construct that up. So I would have that AB squared must be OA squared plus OB squared minus 2 times OA times OB cosine of AOB. Yeah? But for one thing is that, but OA is equal to OB. Therefore, AB squared is OA squared plus OA squared minus 2 times OA cos AOB. Okay? So that means AB squared must be 2 times OA squared minus 2 OA squared cos AOB. Now, let's substitute the values in. AB squared is 8 squared. 8 squared is, let's factorize that out, OA squared into 2 minus 2 cos 36 degrees. Okay, and so OA squared is 8 squared, which is 64, divided by 2 minus 2 cosine 36 degrees. Okay. Now, if you find it correctly, okay, or use your calculator correctly, your OA must be 12.944 centimeters. And that is also equal to the length of OB. Okay? Now, that's the third part. The fourth part of this question is to find the area of the entire decagon. Okay? So the area of decagon is 10 times the area of triangle AOB, which is 10 times AOB would be half times OA, which is 12.944 times OB, which is 12.944, sine of 36 degrees. Putting all of these in calculator, okay, you would find that this is 492 centimeters squared to the nearest cm squared. Okay? All right. Okay, so that is another question down. Okay, also fairly complicated question for standard 2, but this should be quite manageable for advanced students. Okay, now let's have a look at the next question. It said Tina inherits $60,000 and invests in its account, earning interest at a rate of 0.5% per month. Each month immediately after the interest has been paid, Tina withdraws $800. The amount in the account immediately after end withdrawal can be determined using the recurrence relation here. Okay, use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. So in this question, I think the question is fairly clear and fairly obvious of what it tells you to do. So it said inherits $60,000, and so the information given here is that the first money that goes in, okay, would be $60,000. And then what happened is, after every month, the money accumulate the interest, and only after it accumulate the interest, she withdraws $800. Okay, so let's start. So Tina starts by depositing $60,000, right? So start, okay, by depositing A0, which is $60,000. Okay, what happened after that $60,000 sits in the bank for 1 month? Yeah. So with this interest rate that you're given, okay, if you look carefully, 1 plus r divided by 100, this is 0.5% per month that's given to you, so you don't need to adjust any interest rate. So this would be 1 plus 0.5 over 100. So the interest factor would be 1.005. Okay, that's how this 1 plus 0.005 came from. Okay, so we start by depositing A0, which is 60,000. Yeah. Now A1, that means after 1 month. Yeah. Is equal to 60,000 that accumulate 1 period of interest, and then she withdraws 800. Okay, so that accumulate 1 period of interest, okay, and then she withdraws 800. All right, so that's A1. Okay, now it's that the question wants you to find immediately after third withdrawal. Okay, so let us write this out, right? So 60,000, okay, times 1.005, okay, and then she takes out 800. So that's 59500. Okay. Now A2, which is after 2 months. Okay. The recurrence relation is given to you that A of n equals to A of n minus 1 times 1.005. So what we can do is we can just take this value from A1. So A1 times 1.005 minus 800. Okay. And what is that? 005 minus 800. So we have 58997.5. Okay. And A3, which means after 3 months. Yeah. A3 is equal to A2 times 1.005 minus 800, which is 58997.5 times 1.005 minus 800. Now let's calculate that. That is 58492.49. Okay, so here, okay, we have the amount after 3 months. After the first month, we have 60,000. It accumulates the interest, withdraw 800. The second month, that money accumulate another set of interest, withdraw 800. Repeated 3 times. So we have this amount. Okay, therefore, okay, the amount of money, yep, in the account after 3 withdrawals is 58492.49. Okay, and that is the answer to this question. All right. So let's have a look now at the second part of the question, which is slightly harder. Okay, it said calculate the amount of interest earned in the first 3 months. We are only interested in the amount of interest earned. Okay, so the amount of interest earned, right? So you see, when you talk about 1 plus r over 100, okay, this one right here, yep, that's the principal included. Okay, and that r is just the interest rate. Correct? That r is just the interest. So we want to find the amount of interest. Okay, I1 would be, or the interest in the first month, that was 60,000. So 60,000, okay, times how much interest do you earn? You don't earn 1.005, right? You earn only that 0.05%. So we have 0.05 over 100, okay, and that is $300. Okay, now I2, and be careful about this, right? I2 is that 60,000, right, that you have earned the interest from, yeah. So 60,000 here. So just think about this. We want to find the amount of interest earned in the second month. That's 60,000. The money has to be appreciated by 0.05%, and so this must be multiplied by 1.005 because, sorry, this should be 0.5. Yep. Now in the second month, that 60,000 should be appreciated by 1.005 because it has to include the principal amount. And then she made the withdrawal. This is the amount of money left. Correct? The amount left after A1. Correct? And this amount, okay, appreciates by 0.5%. Okay, that amount appreciates by 0.5%, and that gives me, okay, $297.50. Yeah. I3, which is the third month of interest, right? We would have 60,000, okay, squared minus 800 times 1.005 minus 800. This is the amount left, okay, the amount left after 2 months. Yep. And then that appreciates by 0.5%. Okay. And that gives me 298.9875. Okay. Now if you look carefully, 60,000 came from here. And this amount that we substituted, okay, 59500, okay, was actually this one here. So if I want to rewrite that, or I want to use something from the previous part, then this would be your 5950. 59500. And after the third month, we have 5. After the second month, we have 58997.5, right? That 58997.5 was actually here. Okay, that's 58997. Okay, so these are the three interest that has been earned, okay, in the first 3 months, right? And you can sum it, okay? So you can say, therefore, total, okay, amount of interest earned is 300 plus 297.5 plus 298.99, okay? And that would just be the amount total, okay? Plus 297.5 plus 298.99, okay, so that's 896.49. Okay. All right, so that's question 34, okay? Now, let's have a look next at question 36, which is the last common question to both standard and advanced. Okay, now on to the last question. Let's read the question together, okay? A lot of you have heard about this question, so let's go through it in detail, okay? A cricket is an insect. The male cricket produces a chirping sound. A scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. So when you read this question, okay, the information here, it said the relationship between temperature, okay, and the chirps, the number of chirps heard, right? So we're exploring the relationship between two things. Number one, the temperature. Number two, the number of chirps, okay? This 15-second time interval, that's an irrelevant information right there, okay? It said now once a day for 20 days, the scientist collects data based on 20 data points. The scientists provide the information below. This is given to you, so based on this box plot, okay, we have the 13 degrees, right? This is temperature, so 13 degree is the minimum value of the temperature, okay? This is the first quartile, this is the second quartile or the median. This is the third quartile where 75% of the data lies below it, and that here is the maximum temperature. Okay, so we have a few key information here, and then we need to know which one to pick to use. Okay, the mean temperature in the data set is 0.525 degrees Celsius below the median temperature. So the median temperature here is 22 degrees, and therefore what we can do here is we can calculate the mean temperature straight away. The mean temperature, okay, is that much below the median. So the mean temp, yep, is 22 minus 0.525, which is 21.475. Okay, that's the mean temperature. A total of 684 chirps was counted when collecting the 20 data points. Okay, so 20 data points, you've heard 684 chirps. That means one data point, another average, right? Average chirps is 684 divided by 20, okay, and that gives us 34.2. Okay, so that's the average number of chirps heard, right? The scientist fits a least square regression line using data x, y, where x is the temperature in degrees Celsius and y is the number of chirps heard in a 15-second time interval. Okay, so only here we see that x represents the temperature and y represents the number of chirps. Okay, and the equation with line is given to you as well. In this case, it is y equal to negative 10.6063 plus bx, where b is the given to you as well, the slope of the regression line. Okay, the least squares regression line passes through the point x bar, y bar, where x bar is the sample mean and y bar is the sample mean of the chirp data. These information are really crucial to help you to solve this equation. So based on all the information just now that we've analyzed, the mean temp, which is x bar, that's 21.475 degrees. And the average number of chirps, that's 34.2. Okay, so all these information are now analyzed, right? Now let's see. In question 36, it said calculate the number of chirps expected in a 15-second time interval when the temperature is 19. So when we interpret this question, calculate what? Calculate y, okay? We want to find the value of y when the temperature is 19, when x is 19 degrees Celsius. And the question asks you to answer to the nearest whole number, okay? So, number one, okay? Let's do it step by step. Number one, let's go back to what we've analyzed just now, right? Number one, we have that the mean temperature is 21.475, okay? Number one, yeah? Mean temp, x bar, the mean temperature is 22 minus 0.525, which is 21.475 degrees Celsius. Okay. Number two, y bar. Yep. The mean number of chirps. Yep. That was 684 over 20, which is 34.2. Okay. Now two information down, right? What's the next step? The next step, we have that x bar, y bar, right? So I'm just going to write on the side, okay? We know that the mean of temperature and the mean number of chirps lie on the regression line. Yep. Therefore, we can find the gradient of the regression line. Okay, and that is B, right? That's the unknown. Okay, now let's fit that into the equation. Yep, we have negative 10.6063 plus bx. Okay, so y equals to negative 10.6063 plus bx. Okay, and we have that y bar and x bar should fit there as well. Okay, substitute x bar, y bar. All right, so what do we have? We have that 34.2 equals to negative 10.6063 plus b times the mean temperature, which was 21.475. All right. When we calculate this, right, we're going to move everything across to the other side and we're going to make b the subject. So 34.2 plus 10.6063, all divided by 21.475, and that's my value of b. So b is 2.08644, and that is the slope of the regression line. Okay, that is the slope of the regression line. Now, number 4, okay, find y given that x is 19 degrees. Yeah, so we have to scaffold this question ourselves. And you need to understand the given information, how do we use them, and then structure out your response. Okay, so I just break it down by steps for you. Number 4, we find the value of y, or find the number of chirps, given that x equal to 19. Now let's rewrite, okay? Rewriting regression equation. Yep, regression model, we have that y is negative 10.6063 plus, okay, b is 2.08644 times x. Okay, so we have this model here. Okay, that's supposed to be 10. Yep. Now at x equals to 19, right, we are going to make y equals to negative 10.6063 plus 2.08644 times 19. And y is 29.036. okay, which means y is approximately 29 chirps to the nearest whole number. Okay, and so that's how we can structure out this last question here, okay, for the number of chirps. Now, I would want to recommend you to go through these working in detail again, okay, to understand the logic behind how each question is set, especially in the last few questions of the paper, okay. So that would be all of the common questions to Standard 2 and Advanced, okay. In that case, good luck with your study, and I'll see you next time.